Welcome, beautiful nerds, in Monty Paulson's words. So welcome, beautiful nerds, to the Passive House podcast. So I want to share just a little news that happened this week. And that is, here, I'll share my screen, some stuff centered around the International Energy Agency. And this is, so this got a bunch of kind of action and energy on energy Twitter and climate Twitter and in the news and in the New Yorker. Here's Bill Kibben writing about it. The International Energy Agency issues a landmark statement about fossil fuels. And that statement is here. This is a recommendation from the IEA saying there is no need for investment in new fossil fuel supply in our new net zero pathway. So basically no new oil and gas fields approved for development, no new coal mines or mine extensions are required. And the reason that this is a big deal is that this is coming from the International Energy Agency. So this is that they have a number of distinctions. One is that people recognize them as the leading kind of prognosticators about where energy is headed. They were established essentially to guarantee oil supply and to protect the interest of oil producing countries. So they've been kind of intransigent around the clean energy transition, I would say. When the Paris Accord was passed, their statement was that fossil fuels would be a critically important piece of the energy mix for many, many decades to come. So they were skeptical about this transition going on. So this new report is a big deal. I have followed this. I've ragged on the International Energy Agency for a long time. So this is kind of like earth shattering in my world. And part of the reason I've ragged on them is because of this graph from the carbon brief. And to unpack it real fast, the actual is the yearly increase in global solar capacity. So it's showing the acceleration. And then those lines, those kind of horizontal lines, are the predictions, the projections from the International Energy Agency. So for example, in 2015, the actual number of solar capacity added was just over 50 gigawatts. And in their prediction that year was that it would continue at that level for the next few decades. But the next year, it increased to 75 gigawatts. And so they updated their prediction and said, okay, fine, it's 75 now. It'll continue at 75 forever. The next year went up to 100. So they're predicting linear growth, but we're seeing exponential growth. I think they felt like they did a better job last year. This is their prediction last year here. But they updated that prediction. And so last year, the prediction was made in November, this one. But last week they updated it here because there's been a huge increase in solar capacity in the last year. So the point I'm making is that these guys have been extremely conservative in terms of what's going on with the clean energy transition. So they just released this report. This is the net zero by 2050, a roadmap for the global energy sector. And that Bill McKibben quote is from this report. And in it, it has really some interesting stuff about what we should be doing in buildings. So the green is buildings. You can see that it makes up a significant but not a huge portion of the overall problem. I'm going to zoom in so you can see more. Green, again, is buildings. So they're calling for all new buildings being zero carbon ready, which is essentially, it's a envelope first approach to energy efficiency plus electrification. And then by 2040, they're calling for 50% of existing buildings to be retrofitted to zero carbon ready levels. And then by 2050, 85%. So they're a couple of takeaways for what they're calling for. One is that that retrofit rate, it means a tripling of the current rate. So we're just under 1% retrofit rate, and we need to hit 2.5% in order to meet the goal of retrofits. And then the other piece is that on the bottom of this graph here, electrification and energy efficiency account for nearly 70% of building related emissions reductions. So it's a validation of the importance of energy efficiency and all this. So this is the yellow here is energy efficiency. The blue is electrification. So this is the reduction that has to happen by 2030. And then here's the reductions in both that need to happen by 2050. And all of this is, again, a validation of the building envelope approach to energy efficiency in buildings. So you can see that by 2050, they're calling for significant building envelope improvements, both in retrofits, which is the dark green, and in new zero carbon ready buildings here. And then lots of heat pump stuff. That's what the blue is. So my toast for everybody is a toast to being on this pathway to zero carbon by 2050. And you know what? The International Energy Agency may be on board. So here.
Cheers, everyone. Stay the course.
Yay.
Yay. All right. So thanks for listening. Now let's move into small breakout rooms. And maybe you can reflect a little bit about that or say hello. We have a little bit, probably a couple more minutes than normal. So let me get you organized here. Sorry, I'm wearing a couple more.
No worries. While Zach's doing that, Lloyd, again, thank you for joining us and thank you for your article. I look forward to reading that afterwards. So thanks for diving in that as well. And Jason's put out there. So yeah, a big Mark Willie thumbs up to stay into our path. So.
All righty. See you soon. Okay, but we want to get to our presentation from Melissa, which is going to be awesome. So I'm going to do some really fast announcements here. So on the Passive House Accelerator website, every week we publish a week in preview article. And that is here, Explore Articles, and then you can find week in preview. And that summarizes what's coming up for the coming week. And I'll talk about that, resilience in Canada, later tonight. Great construction tech yesterday. Of course, we have Melissa now. And I just wanted to give a shout out to this episode 39 of the Passive House podcast. We have over 30,000 downloads now of the podcast, which is pretty cool. And this features a conversation that I had the pleasure of having with Bomi Jung, who was at the New York City Housing Authority for several years and now is running Topside Advisors. Really great conversation about affordable housing and passive house and climate justice. So please check that out on the Passive House podcast. Also, some really great stuff coming up in terms of conferences and summits, including the Passive House, North American Passive House Network's Passive House for All Summit on June 10th and 11th. This
Hi.
Hello. So this is going to be both in person in New York and also virtual. So please check that out. And then we have Passive House Open Days coming up as well very soon, and lots of great socials, including Building Science Fridays with Mark Willie. And this will be focused on vapor, moisture, and bulk water in our buildings. Also, lots of educational resources here to tap into. All right. So with that, we're going to move to the presenter, Melissa Furukawa, and I have the pleasure of introducing Melissa. She's a Passive House Certifier and Consultant, and she has got experience in low energy building design and analysis, of course. She completed her Master of Building Science degree at Ryerson University. She's worked on a variety of projects all over the world, designing buildings that are climate responsive by incorporating passive design elements to maximize user comfort while minimizing energy use. She has extensive experience in energy modeling, daylight analysis, climate analysis, as well as other engineering analyses. At Peel Passive House, Melissa supports the company's certification, consultancy, thermal modeling, training, and research activities. Her project experience ranges from single-family homes to apartment tower retrofits, and she's also worked on non-residential projects, including a community center and church. She's involved in the company's window modeling services, working with manufacturers to get their products certified to the Passive House standard. Melissa is the training manager at Peel Passive House Consulting, and she manages the company's online training platform and teaches courses related to Passive House. So Melissa, thank you so much for joining us tonight. Please take it away.
Thank you, Zach. Thank you, everyone, for joining my little presentation today. My name is Melissa Furukawa. Yeah, that was a pretty good intro, so I don't think I need to introduce myself, but today I'm going to be talking about some lessons learned from a certifier on Passive House projects. And I know some people maybe do FIAS and some people do PHI. We only work with PHI Passive House, so my presentation is going to be focused on that. I think Zach already touched on this, but just a brief background on the company. So I work for Peel Passive House Consulting, started by Andrew Peel, who I'm sure most of you know. We do everything Passive House, so Passive House Consulting, Passive House Building certification. We're also getting more involved in component certification, including windows and wall systems. We do Passive House research as well as Passive House training. So I'll just jump right into it. The first tip I want to give to you guys is to use the check worksheet on PHPP. I think this is a great tool that's often overlooked. It's one of the first orange tabs. And if you go to the check worksheet, the first thing you get is kind of an overview if you have any errors in your PHP. Please don't submit your PHP for design stage review if you still have a bunch of errors. So that will kind of point you to where your errors are in your PHP. And then if you scroll to the bottom, there's this plausibility check, and you have to unprotect the worksheet to access it. But once you unprotect it and click that plus button, PHPP does a kind of sense check for your different inputs. So for example, it'll check and it'll flag for you if the areas you input on the areas worksheet is different than the ground worksheet. So you input the floor slab, for example, on the areas worksheet, and you have to input an area also on the ground worksheet. If those differ, PHPP will flag it for you. If you input a really low UG value for your glazing, PHPP will flag that for you. So it's just a really good kind of sense check for your PHP modeling. So really highly recommend that you utilize that often overlooked tool. The second thing I want to talk about is plumbing stack thermal bridges. So in a building, there's usually a vent stack for the plumbing. And because the vent stack is vented to the outside and also connected to the sewer system, you can get a lot of convective losses through the vent stack. And this can add up, and oftentimes it's overlooked and people don't input that as a thermal bridge. And this could add a substantial amount of heat loss and potentially put you in danger of not meeting that space heating demand. So a few things you can do. One thing is you can install an AAV or an air admittance valve. You may need like special permission to do this. It's not always, depending on where you are, readily accepted by code. Basically, it's a little kind of cap that goes at the top of your vent stack as it exits the roof, and it prevents air from coming in. But if you, for example, or escaping, but if you, example, flush your toilet, then it allows for air to be drawn in as required. But otherwise, it's kind of capped off so you don't have that open convection loop. If you can't install an AV, if you're not allowed to, you can you can insulate your pipes. You want to make sure that you're insulating the entirety of the vent stack and just including that thermal bridge in PHPP. PHI did come up with this new calculator for calculating the heat loss of drain pipes because it can get quite complicated, especially for multifamily. You have to include all of the relevant pipe networks. And yeah, if you're not sure how to use this new tool, because it is, in my opinion, not super straightforward, I'll just speak to your certifier. But this tool does give a more accurate prediction for the heat losses caused by these vent stacks. So before, I don't know if you know, but there was a little additional tool underneath the thermal bridging section of PHP in the areas worksheet, and people would just use that. You would input your diameter of your pipe, how much insulation you have, what's the conductivity, and get a psi value. And that was basically overestimating, especially for larger buildings. So that's why PHI came with this new tool. So I highly recommend you check that out. Next thing I want to talk about is FRSI issues. So sometimes, I mean, a lot of times we can just use conservative estimates for thermal bridging. Let's just say you have like a particular door install and you don't want to do thermal bridge modeling, but you know that there's a thermal bridge there. You may just use a conservative estimate. And that can be fine. But the issue with that is if you're not doing the thermal modeling, then you don't know what the minimum temperature is. And if it's a large psi value, if you know that there's going to be thermal bridging, a lot of thermal bridging there, then you may also have an FRSI issue. So this table here is just a little reminder reference for, you know, the different climate zones and what the minimum FRSI temperature needs to be. And again, this is just a reminder how we calculate the FRSI, which is the difference between the minimum surface temperature minus the ambient temperature divided by the indoor temperature minus the ambient temperature. So if that minimum temperature is too low, then you may have condensation and mold risk issues. So as an example, for this door install, you know, maybe we don't have the time or the budget to do the thermal bridge modeling, and we just assume, you know, a high psi value for the install, and that can be fine. But if we don't do the FRSI calculation, then we may miss that actually, you know, if this is cool temperate, this is not meeting the criteria because this FRSI is calculated 0.681 and the criteria for cool temperate is 0.7. So in this case, you know, you have to either improve this detail or put a heat source nearby so that you make sure that that surface doesn't get that cold. Another thing that we also see often is rooms that are not ventilated. So all rooms should be either directly or indirectly ventilated. So in this floor plan here, this study room is not being ventilated. It's not going to get any transfer air either. So, you know, a supply air vent should be added to this room. Another example of a room not being ventilated properly. So this is a studio, 1-bedroom apartment, not 1 bedroom, but just a studio apartment. And you can see the supply is kind of here near the entrance and the extract is in the kitchen. I mean, there's also an extract in the bathroom, but basically it's very questionable if the air is actually going to be circulated properly in this kind of living bedroom space, because probably what's going to happen is this supplier is just going to short circuit and go out to the kitchen. So in this case, we suggested that this supply vent be moved further into the space, more like in this bedroom / living room area. This is another example of another project where, so it's 1-bedroom apartment, we have supply in the bedroom and in the living room and extract in the bathroom. And actually there is no extract in the kitchen. And in this case, again, it's kind of questionable whether the kitchen is going to be properly ventilated. Most likely the air is just kind of come from the living room, bypass the kitchen and go straight through the bathroom. In this case, like we would typically recommend an extract in the kitchen. Unfortunately, this is another kind of side tip, like have your certifier review your design at the design stage, because you know, often what happens is people come and the building's already constructed and they want to do design stage review. And at that stage, like it's really hard to make any changes. And that's what happened on this project. So our kind of after the fact solution is to put a transfer grill in this kitchen pantry, so that at least, you know, there's potential for some air to come here and go through this transfer grill and be extracted through the bathroom. Another point around ventilation and mechanical systems is, so if you're using fan coil units for heating and cooling, yes, sometimes in the design, people will have the ventilation supply air go directly through the fan coil unit. And this can be fine. The issue with that is that the fan coil fan then needs to run even if there's no call for heating and cooling. So in those shoulder seasons, there's no reason for the fan coil fan to need to run, but because it's now the air is being pushed through the fan coil unit, it will have to run. So you either need to account for this additional fan coil energy, and if your PHPP can handle that, if your PE limit is okay, maybe that's fine. Alternatively, you have a bypass damper so that if there's no call for heating and cooling, then the fan coil unit can be bypassed. Moving on, so around cooling, we all know that if you don't have mechanical cooling, then there is a limit for the frequency of overheating. It is 10% for certification, but just a reminder that this is like an absolute maximum, and we know that our climate is changing. We know that we have to do something about it, as Zach was pointing to, and so it's really not a good idea to work with that 10%. We are now, the guidance from PHI is to work with at least less than 5%. And then oftentimes we're also suggesting to clients that they make provisions for cooling because they most likely will have to retrofit it later on. Yeah, and so when you're looking like at meeting that overheating risk, you also want to consider what are your assumptions to getting to 10%, 7%, 5% overheating risk. Are you assuming that your occupants are going to leave their windows open all day when they're going to work during the day? Or is the project in a busy downtown area and you're assuming they're going to leave their windows open at night, which it's questionable. So it really depends on your location. There's no kind of fixed rule of thumb for this, but just speak to your client to really assess like what is the culture around window ventilation, natural ventilation. And the other thing you can do is a stress test. So you can test like, okay, if I look at no window ventilation, how much does my overheating risk increase? If I'm assuming they're like we have internal blinds and they're not using it, is that going to really push us over the edge, for example? And your certifier will do this stress test too when they're looking at your building design, but it's also good practice for you to do that as well. Yeah, and just as an example where this like really happened at a project was nighttime ventilation was modeled and assumed and everything, the PHP said it was okay. But then when the project actually got built, they didn't put in the bug screens. So nobody was using their windows for ventilation. And there was a lot of complaints of overheating. And so at that point, it was too late to go back to window ventilation because everybody was very upset. So they had to retrofit in mechanical cooling. So yeah, just something to be aware of. Yeah, this is just a quick example of, if we assumed 6 windows open 8 hours during the day and 8 windows open all night, maybe we get a frequency of overheating around 3%. And then, we do a stress test and we say, okay, what if we had no windows open ever? Now we're at 14.8%. So, the reality is probably somewhere in between. And yeah, just to get a sense of this and to talk to your clients to see, where's the truth or where's the most reasonable assumptions going to lie. I think this is my last thing about supply air cooling. So if you're doing supply air cooling, I think this is often overlooked. You should check on the cooling load worksheet that your cooling load can be met via supply air. There's a similar thing on the heating load worksheet. But even if the cooling units worksheet shows that the demand is okay, so it does a little calculation. It says, this is the sensible demand, this is the latent demand. yes, it's meeting, the system can meet it, but that is the overall demand for the year. Whereas on the cooling load worksheet, we're looking at like the peak day. So if you scroll all the way to the bottom, you'll see the result. So for example, in this project, the cooling load was 6 watts per meter squared. But if we have 14.7 degrees Celsius supply air, then it could only, the supplier could only supply 4.3 watts per meter squared. So not enough to cover the cooling load. So, I mean, there's different options here. Like you could maybe increase the amount of shading so you have less solar loads. You may want to increase the airflow rate in the summertime. Yeah, but if you're going to rely on supplier cooling, you want to make sure that this cooling load can actually be met. Okay, so in summary, just like really engage with your certifier. They are a great resource for your project. Engage with them early when you can still make design changes. If you have any questions about certification, if you're not really sure, like, is this okay? Then, use them as a resource. That's what they're there for. Keep the certifier abreast of any changes, the timeline. And yeah, if you're not sure, if you have construction changes that happen during construction and you're not sure, vet them through your certifier as well. So that is what I have for you today. Thank you for listening.
Fantastic. Thank you so much, Melissa. Great insights and tips for all of the practitioners here on the call. And there's been active chat, so I'm going to hand it off to Sean, who will take it away as Q&A concierge tonight.
Perfect. Thanks, Zach. Thanks, Melissa. Just take a sip of whatever beverage you have, because there's a couple of things I wanted to point out. Number one, Julie's in the audience. Julie, do you want to just talk about your project? She was in our breakout room, and I like to give new Passive House projects a little shout out. So, Julie, do you want to just give us a little update of your exciting news?
Sure. Well, we've been selected to design the new City of Mount Vernon Library, Community Center, and parking garage, and it will be all electric, passive house, and low embodied carbon, and much, much more. So we're excited to get started on that project.
Congrats.
Thank you for that. Again, another example of what we should be doing. So thanks, Julie. We look forward to getting, again, videos and presentations from you. So, this happens, you get to announce it, but then we get to suck you in for all the juicy data that you get to do from it. So we look forward to that.
It just means I'm going to be leaning on all of you heavily for the next year.
We are here for you, just like you've been here for us. So it's a team. And the other, and so Peter, my good old friend PH Molnair, had a question for Zach. So he can start, and then Hans will fire things up for Melissa. So Peter?
My first question was actually to Zach.
Yes.
Pardon me, did you get a reply from our good Mr. Biden? That's curious.
I have not heard back from Joe yet. I'm waiting patiently. I think he has some other stuff cooking right now, but so I'll give him a little longer.
And Peter, did you actually have a question from Melissa as well that I didn't know about?
Might have. Yeah, sorry,
no? Okay.
That's gone off my head.
No worries. Just let me know what it is. I'll get you back in the queue.
Thank you.
But Hans had a question. So Hans, over to you.
Hey, Melissa. This was a great presentation. There's so much that we can geek out on. I had never thought about the stack, and so my question was really about the insulation around the stack. How much do you see generally?
Yeah, I think the general rule of thumb is around 2 inches.
Because that also includes all the other supply lines and everything.
Let me see if I can go back to that schematic. So not the branches to the different fixtures, but just like the
main one,
the main stack that connects from whatever the roof to the sewer. And there might be depending on your building design, there might be multiple stacks. So like in a multifamily building, sometimes they'll like group some suites together and they'll have like 5 or 6 different stacks. In a single family home is probably just one stack, the height of the building.
Yeah, cool, awesome, thanks.
Thank you.
Thanks, Hans. Now, Justin, you had a question more about the link that you were requesting. So we'll try to find that link. But Justin, you always usually have other questions. Anything else you needed to ask her?
Thanks. Well, the only other question, which is something I've asked her, hi Melissa, you before, is if you guys are ever thinking about having a Passive House PHPP class focused solely on the mechanical systems portion of the PHPP. But that's not a specific question.
Oh, yeah, no. I haven't. That is, I think, a good one and important. We do have a PHPP expert course now. I don't know if everybody's familiar, but a PHI came with this new seal, this PHP expert seal. You have to write like an additional exam to get it. And we have a course. It's not just focused on mechanical, like it's also looking at like basically everything that's not included in the basic PHP course. So more like non-residential or multifamily buildings, how to model multiple HRV systems, how to model like a heat pump. Yeah, I can't think of everything off the top of my head, but we do have that, which has some of that. But yeah, no, I think that's a really good idea, and we will consider that.
Thank you.
Yeah, I don't see Andrew here yet, but he might be on a different screen, but I'm sure he's taking notes because like everything else, we always have to improve the education that we're providing. So if not, Melissa, I'll definitely pass it along. Thanks, Justin. Over to Jeff Rodine.
Great presentation. Being new to PHI, this is just the kind of tips that I need. So thank you. Perfect timing. My question is on the stack, are the energy losses that have to be modeled both conductive and convective, or one or the other? And about how much energy actually goes through one of these, like what's the psi value or typical psi value for one of these?
Yeah, I mean, it depends. So sorry, your first question was, yeah, this tool will kind of calculate all of the heat losses.
But just from a building science, there are the convective losses from the air movement, and there's also the conductive losses of the pipe itself.
Yeah, and it's mostly the convective losses. So there will be some like it'll be like a point thermal bridge, right? But it's just one point. So it's in the overall like scheme of the building, it's not that much. And yeah, the psi value really depends on your like the network and how much you insulate it. Yeah, I don't have like a figure at the top of my head.
I'm just curious. I mean, if you run through the model, I mean, are we talking like 0.1, 0.2, 0.8? I don't know. I mean,
no, not that high. Yeah, but not thermal bridge free either. Right. Yeah, I'd have to pull up something to give you an answer.
No problem. Thank you very much. You're fine. Perfect.
Jeffrey, in most of the models we do, it's about 1 kilowatt hour per square meter per year.
Okay.
Thanks, Scott, for chiming in. I'm glad that he put that in the chat too, because I noticed that. So, all right, so we're gonna kind of go up a little bit. Well, I know we're beautiful nerds and we like to geek out, but we'll try to get to some easier questions for Melissa. So, Susan has a couple. So, Susan, over to you.
Oh. Yeah, well, give Susan the easy questions. I've got the easy questions. Hi, Melissa. I just wanted to thank you for all the great work you do. You've been helping me and studying for my my exam. I'm scared shitless, or Sorry. My question, well, I can't even remember. I think one of them you guys were talking about opening the windows, and I know we often have conversations about that. Oh no, two questions. Oh, I had two questions. First question was about the kitchen, and I got to ask it, everyone, we always have this conversation. What about venting in the kitchen? What are your thoughts about ventilating and extracting in the kitchen? That's my question number one. And I'll ask number two after
Do you mean like with the range hood, like having a recirculating
Yeah.
versus, I mean, we do recommend recirculating range hoods. I mean, just because the heat loss with you can maybe try to make it work. I think for our climate, it would be challenging, just because even if you only put it on for like half an hour a day, like the CFM, the airflow of those range hoods is huge. And I mean, now we have range hoods that have, nice carbon filters. So I think that it's okay from an indoor air quality perspective. So that's generally what we are recommending, but you can still do, like, PHI has guidance on how to model direct vented range hoods. The main thing that you want to make sure is you have like an airtight damper. So you're not, because you want to have makeup air. You're going to be extracting like large amounts of air. And if you don't, you're building your building airtight. So if you don't have makeup air, then it's going to mess up the pressure. So you want to have makeup air, and you most likely, I mean, for our climate, you'd want to also, so I don't know where everybody else is, but I'm in Canada. So you definitely want to heat that makeup air, so that, for indoor air quality and comfort.
Great, thank you. Just thought I'd throw that one in there. And the second question,
everybody has
I know. I'm not letting anyone else say anything. No one else gets to say anything. Okay, that's it. Moving on. Next question was talking about the open window, and the chat was lighting up about the windows in the bedrooms.
Oh, okay.
And so then you talked about the bug screens, but I'm just wondering, has there ever been a study about how the screens reduce airflow? Is there anything about that?
Oh, yeah, good question. I mean, we do recommend that you model like the bug screens in when you're in the SunVent worksheet, to also consider the bug screens. I don't think we have like a good number for it, but just as a rule of thumb, for when you're modeling shading for bug screens, we usually use a factor of 0.7. So of shading factor. So we just have been using the same. It's probably like overly conservative, but we just have been using the same assumption for window.
Those are my two questions. Thank you.
Thank you, Susan.
Another good ones. Thanks, Susan. And heading over to Ian. Ian in the coop.
Hi there. I guess I'm talking about AAVs a lot and in the chat, and also I guess actually the main one was for bedroom doors, instead of doing undercuts, the suggestion to use the product from Washington State. That's actually it's a University of British Columbia kids who made it as like their business school project and started up a company essentially out of it, which is the Van Air doors. So they allow airflow to be tuned. They've got two different ones, but also it actually has a nominal and pretty decent STC value as well. So you can actually have like, decent sound protection between rooms, but still allow airflow. So they're kind of cool.
Is that those doors with like the slit in it?
Yeah, the slit in it, yeah.
Yeah, it looks really nice too. Aesthetically, I think.
And you can get them in wood or paint grade or whatever. So they're like $100 nominal more per door than a regular door. So for most projects, it's probably not too bad. For one of Scott's multifamilies, maybe it would break the budget, but for like a house, when you need 3 of them, like seriously, it's not even something to think about.
Ian, you good?
Yeah, I'm sorry, that was bad. Yeah.
No worries, bud. I appreciate all the comments you had in the chat to direct us, with the AV stuff. So again, thanks for at least chiming in there. We're gonna go back to Peter, who remembers his question. Peter?
That it was back to what he was saying. How do you provide the supply air for the plumbing drain vents? You were talking about AAVs, but to eliminate the perforation through the roof.
Sorry, can you repeat your question?
Yes, that I was just back to the question that you had sort of discussed with Ian. I was wondering about how to provide supply air for the drain system and the plumbing, other than to eliminate the perforation through the roof stack. AAVs is one way,
Yeah.
but is that the solution?
Oh, is that the solution? Yeah, the other option is you can insulate the whole vent stack. That will like at least help reduce thermal bridging. Another thing that I don't know if I've seen it in practice, but there is something called a backwater valve, which basically stops sewage from overflowing into your home. But it has like this little flap. So if the flap is always kind of closed, then it will only open when you flush your toilet or you use water. But otherwise it's closed. So the idea is basically you want to close it on one of the ends. So the AAV closes it at the roof. This backwater valve would close it at the sewage. And if you close it at one of those ends, then you won't have as much convection loss.
And then
So that's
Studer has
another.
something to insulate the house with that you put outside the building that allows air to freely go into that stack there so that you can't get the back pressure from the sewer. It's just the maxi valve or whatever. And basically it's just got a filter in it. It doesn't actually have a blockage for air going one way or the other, but it allows for the air admittance that you need to be able to insulate yourself from the sewer.
Peter, does that help?
Yes, that does solve it. Thank you very much.
Gotcha. All right, Melissa, we're going to give you a break because I've had a lot of people say that we went too fast in our breakout rooms. So I believe Zach has the ability to send us all back. So we're going to go spend a few more minutes connecting with our group. So we don't often do this early in the show, but people have either complained or demanded or asked nicely, all the above. So off we go. See you in a few more minutes.
Fantastic. Well, I hope that you're happy, everybody. And that you had a good conversation. I'm going to do some closing stuff here real quick, and then we'll get back to if Melissa's able to stay, we'll get back to that. So let's see. Sorry, I need to share my screen. Okay, so everything that we do at the Accelerator is thanks to generous support from sponsors. Nothing would happen at the Accelerator were it not for the underwriting of these fine organizations. So I want to give them a big kudos and thank you. Our founding sponsors are 475 High Performance Building Supply, Baxt Ingwe Architects, Mitsubishi Electric Train HVAC US, Partel, Glavel Foam Glass Gravel, Minotaur All-in-One HVAC and Dehumidification, RDH Building Science, Rockwool North America, Stocorp, and Zola Windows. Our champion sponsor is Sika, and our stakeholder partner is NYSERDA. Thank you also to our patron sponsors, Aero Barrier, BR+A Consulting and Consulting Engineers, Brennan Air Tightness and Insulation, Inotech Windows and Doors, and US Engineered Wood T-Stud.